Hello viewers, welcome back. So we are done with our model. So if you have a look out there, so it is a huge model out there. So now we will be loading weights from a pre-trained model, and the weight file I will be giving the link of the weight file. You can download that weight file, and from that weight file I will be put the weights to my tensors, to my model. So for that reason I have to define a function. So open a Python file, new Python file, and defined as load weights dot py. Okay, so let's begin how to define the function. Import NumPy as np. So I will be needed this and define load weights, and I have to give model out there and weight out there. So weight file out there. So open file. So open weight file, and I will be giving in right mode. Okay, so major, minor, then revision, then C. So these are the 5 from file. So I will be importing these 5 elements from the file as data type of NumPy in32 and count equal to 5. So I will be importing these 5 elements from my weight file. Now just define j equal to 0 for I in range of 75. Now so you can see, if I show you the model, okay, for every layer there is a name, okay, by default. So you can see there are conv 74, so the maximum convolutional layer which have a name of convolutional 2D 74. So and you can also see there is a batch normalization layer. Okay, so these two layers will need weights. Okay, now I am going to feed weights to these layers. Now now I will be giving layer name equal to conv 2D underscore %d, and I'll be putting here %I. So here I will be having a value from 0 to 74. So if I iterate through a for loop, then I will be having all the names of convolutional layers. So %I, sorry, %I, and pass out there if I greater than 0, else con. So the first convolutional layer has a name of conv2d, and the rest of them will have 0 to 74. And binary, sorry, bn layer, so batch normalization layer name equal to batch normalize, or so this is the name out there, you can see batch normalization. So normalization underscore %d out there, and obviously I will be giving the name out there by j, %j. So if j greater than 0, else batch normalization. normalization. So otherwise the name will be only batch normalization. So conv layer equal to model dot get layer. So the model which we have created previously, I will take the layers from that model. So conv by giving the name of layer. So it will bring that convolutional layer from that model. Okay. Now I want to learn the filters equal to conv layer dot filters, then k size, so k size kernel size equal to conv layer dot kernel size, just first limit will do, then in dim, so inner dimension will be on layer dot input shape minus 1. So do I define, have I defined input shape? Okay, so boom 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 boom. Okay, so from conv layer dot input shape, I'll be having the channel number over there. Okay, so if I not in not in 58, 66 and 74, so in this layer of combinational there is no batch normalization, so I will be keeping that differently. So darknet, so I will be putting here a comment darknet weights. So the format of darknet weights are beta, gamma, and after that the mean. So for batch normalization I need these three parameters and variance. So but in the TensorFlow there the gamma is first, then beta, then mean, then variance. Okay, so keep this in mind. So bn weights weights equal to numpy dot form file. I'll be importing this data type equal to numpy. So the weight file will have Yolo V3 dot weights, and you can download from my given link, or you can go to the GitHub link and download from there. Data type equal to numpy dot float 32, then count how many element it will bring. So it will bring equal to 4 into filters. Okay, so bn dot weights equal to bn dot bn weights dot reshape. So I'll be reshaping this one to a shape of 4 by filters, and so I will be bringing the gamma forward, so gamma and then beta and the rest of the 2 and 3. Okay, so I am the rearranging the area out there, so just put out there another. So bn layer equal to model dot get layer equal to bn layer name. So I will be getting that layer. So then I have to increment the j out there. So increment j plus equal 1. Else I have to give out there conv bias equal numpy dot from file and give out their weight file and data type. Data type equal to numpy dot float 32 and count equal to filters. So if there is no batch normalization, I will be needed only the parameters equal to number of filters, and when there is batch normalization, I will be needed inputs weights 4 times of filters. Okay. Okay, now conv shape equal to filters, then in dime, then k size, then k size. Okay, now conv weights weights equal to numpy dot form file. I'll be bringing data type equal to numpy dot float 32 and count count equal to numpy dot product equal to conv shape. Okay, so this is the I'll be bringing this number of elements. Now conv weights, I have to reshape them. So conv weights dot reshape, and I'll be using conv shape out there. So conv shape and dot transpose equal to 2 3 1 0. So in the darknet dataset, the shape is output dimension, then input dimension, then height and weights. But for TensorFlow, I need the height first, then width, then inner dimension, then the outer dimension. That is the size of that kernel first, then the channel number, then the what should I say, number of filters that I am going for in the next convolution. So if I not in, so 58 66 and 74, then I will go here on layer dot set weights. So I'll be waiting sets weights equal to, I am passing on weights, and after that I'll be passing bn layer dot set weights. I am passing bn weights. Now else I'll be going for passing on, so on layer dot set weights, pass out there convoids are, and the con bias. So con bias out there. Now did I define con bias? Yeah. So this is all, and I can assert, so assert if there is no weight file, then read 0 equal 0, then put out there now I will be closing the white file. So white file dot close and returning the model. So I am done with my load weights file. Okay, so this is all for this tutorial, and in the next tutorial I'll be going for detection. Thanks for watching.